Hi there, welcome to data collection part 3, non-random sampling. It's quite simple, so you just need a good solid biscuit like a ginger crunch cream, I think will go today. But yeah, there's two things. It is simple, but it's really, really important because it's one of those things that in the exam that often people just go, oh, I just cannot remember that. So it's one of those things that we need to get into, and you just need to revisit it regularly so you remember what the words mean. We've got two important words, can I point them? Opportunity and quota, two very similar sorts of sampling. So let's crack on. So there shouldn't be too many notes to make here today. Everything that's written down here and that I'm going to write down you'll want to do as notes, and then we'll just have a few examples. So the two sorts of sampling, as I said, they're quite similar. Opportunity sampling, also known as convenience sampling, so it may be called that when you come across it, is just going up to the first few people that you can find. So if you want a sample of 20 and you're thinking about shopping, you go to a shopping centre and just ask the first 20 people that you find. So we're selecting a convenient sample of the size required. So in green, that's your definition, and examples in blue. So 20 students in a school that you want, go to the library and ask the first 20 students that you see. Now quota sampling is very simple, only it adds a bit of representativeness to it. So one thing that we often want is the same number of, we want it to be representative of boys and girls, for example. So if there were more boys in the school than girls, you would want slightly more boys, and you would get, or if there were the same number, you might just go along and ask the first 10 boys and the first 10 girls that were in the library at the time. So here's our definition, selecting a sample that represents the different groups of a population. And in my example, I've just gone a little bit further than just doing it boys and girls. If you had 5 different year groups, you could have, actually does that make 5 boys? Yeah, you could have, that would need to be 2 boys and 2 girls from each year group, wouldn't it? And just find the first boy from year 7, first girl from year 7, and first 2 of those, and so on. So we're going to move straight on now. Before we have questions, we also need, you will always be asked about the advantages and disadvantages. And the basic big advantage of both of these is that they are quick and that they are cheap. Oh, and third, that they are easy. So those 3, quick, cheap and easy, are why we do them. And the disadvantages are always just simply that because you haven't got a random element to it, you can very likely that you're going to get bias creeping in to what's going on. So we'll just draw up a quick table now of advantages and disadvantages before we move on. Advantages then. It's easy to do. It's cheap. And it's fast. And same again for the other one. Other things that you can say is no need for a sampling frame. So if you remember from last time, a sampling frame is a numbered list, isn't it, of everything that you've got. And again, you don't need a sampling frame for quota. But there is an added advantage for quota in that it's going to be more representative. So, quick way to represent all characteristics of a population. Now the disadvantages are very, very simple too. They're both not random, so they can both introduce bias as a result. Now the next ones are slightly different, and they reflect the difference in what's going on. So the other disadvantage of the opportunity one is that it's unlikely to be representative. And whilst the representativeness of the quota system is an advantage and desirable, it's going to take a little bit of effort. So that becomes a disadvantage, that quota sampling is not quite as cheap and easy as the other one. So that's going to create a cost. So dividing the population into groups can be costly and time consuming. And now the bit you've been waiting for, an opportunity to answer some questions. Right, so now we're at the pause and give it a go time. Good idea to write the question down as well, because then it'll mean something when you look back for it for revision later on. So give it a go. Right, well the similarity is that they both generate a representative sample, and what we mean by that is dividing the sample so that the characteristics of the population, the various characteristics, are all proportionately represented. And then the difference is, quite simply, that stratified is random, as is actually said in the question, whereas quota is not. And if you're not sure what I said, or you want to copy it down now, pause the video and do that. Next question. Nice one about deer. Give this a go. So the sampling method here, because you've got 5 males and 5 females, it's not just opportunity, it's quota. And one advantage of this method, well, there are several. It's representative. It's representative of the population is a nice one, but also you can go for all of the quick, easy, does not require a, wonder if any of you can guess what I'm going to say, sampling frame. Okay, moving on. The masses of the sampled deer are listed below. Use the sample data to compare the masses of male and female wild deer. Now, we haven't talked about this yet. This is just like what you'd have done for GCSE at this point. So hopefully you've done something like this. Work out what the means are of each of them, because you have to compare an average and the range whenever we're doing this. So that's 82.4 for the males. For the females, hit the fraction button, and then 67 plus 72 plus 75 plus 68 plus 65 all over 5 equals S to D 69.4. So we can say that the average male is heavier than the average female. And then what are the ranges? So male range equals, what's the smallest? 75 to 90 is 15. Female range is 65 up to 75 is 10 kilograms. So then you can say that the males' masses vary more than the females. And that's all there is to that one. Finally, suggest 2 improvements scientists could make to the sampling method. So do that now. And one improvement that always works whenever you're trying to get a better sample is to increase the sample size. And then the other thing we need to think about is what is wrong with quota sampling, which is what's happened here, and that is that it's not random. So you need to introduce a random element in some way. So one thing you could do is capture deer at random times of the day, for example. I suppose something else you could do is catch lots more deer than that and then make a sampling frame and make a list of them and then pick them from that. But that would take a lot more effort, wouldn't it? But yeah, something to randomize it. Okay, we've just got one more question to go, and that'll be that. Right, there will be 4 parts to this question eventually, but have a crack at the first 2 first. Right, so an opportunity sample is, I'm just going to take the first ones that you get. So 1, 2, 3, 4, 5. And I suppose I should write those down, really. And that's all that is. Systematic sample, starting from the second data value, so it's going to need to be 1.9 for the first. Then 20, we need 20 divided by 5 equals 4. So it's every 4th value, isn't it? So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And hopefully that should give us exactly 5 values. Right, okay, moving on to the last 2 parts. Calculate the mean height. So you may need to go back to find what all the data was to do that, and then state with reasons which method is likely to be more reliable. So there's the values if you need those. Right, so for each sample, the first sample was 1.8, 1.9, 2.3, 1.7 and 2.1, so you'd need to divide that by 5, and then the second sample was the 1.9, 2.0, 2.6, 2.3, 2.0, divide those by 5. So that should have given you 1.96 meters for the first one and 2.16 for the second. Right, now stating with reasons which sampling method is likely to be more reliable. Well, first up, of course, the systematic. And why is it more reliable? Since it is random and more likely to be representative. So that's one thing saying why systematic is good. What was the other one? It was not quota, was it? The opportunity. What might happen? Well, they were all smaller, weren't they? The first 5, it might have already been ordered, or the ostriches that were smaller might have been easier to catch. So the opportunity sample is more likely to contain all the smallest ostriches. For example. Now there are quite a few different ways you can come up with things that can be sensible, that you can get a mark for. A lot of people don't like this sort of maths because it doesn't necessarily feel totally like it's maths, but it is, because it's all about logically making things as fair as possible. All right, well that's it for today. Next time we will be moving on to part 4, which is types of data. So have a little think about what types of data do we have, and we'll do that next time.